Okay, we are going to go over this in class, but I thought I'd make a little so you can refresh yourself. We are talking about linear relationships today. So when we're dealing with linear relationships, there's a few things I want to make sure that you're very comfortable and you know them. So first of all, you need to know that linear relationships, you can tell if they're linear by looking at a table, a graph, or an equation. And you know a relationship is linear if its graph is a straight line. So remember when we talked about the root word, linear, there's line in there, that should help you out. So if its graph is a straight line, it can be any direction as long as it's straight, okay, then you know that's linear. If in a table, you know it, if one variable is changing by 1, then the other variable has a constant rate of change. So usually you might see something like this, x, y. X might be changing by 1 here, and y might be, if it starts at 10, now it's going 7, 4, 1. You can notice that it's going down by 3 every time. So when x is changing by 1, y has a constant rate of change. That means it's linear. If x is skipping around, you need to be a little bit careful and fill in your gaps. But this is a good way to tell if something is linear by looking at a table. In an equation, you can write it like this. The dependent variable, which is usually y, think about your xy axis. Okay, so the y usually equals the rate times the independent variable, which is usually x, plus the start value. So like in the example before, the rate would have been -3 because it was going down by 3 every time. And the start value when your table starts and x is 0, y is at 10. So your start value is this. Equation could look like that. Y equals -3x plus 10. But it's always going to be written in that form. Dependent equals rate times independent plus start value. It will always have that possibility, unless it's a vertical line, but we can talk about that another time. All right, I'm going to give you 3 questions from either a table or graph or equation, and I want you to see if you can figure them out on your own and then come back and check. So the first question is it linear? And if it is, you have to answer questions 2 and 3. I want you to figure out what's the rate of change and also what's the start value. So let's look at this first graph. Okay. And if we're looking here, it's a straight line, so I think we're going to answer yes, it's linear. Okay, it has a straight line. I think you can see that just from looking at the graph. When we're looking for what the rate of change is, I want to kind of look up here. It looks like every time that x is going over by 1, y is going up by 5. That's happening every time. So the rate of change is how much it's increasing every time. So the rate of change is 5. It's going up by 5 every time. And the start value, that's where does your graph start, like when no time has passed or nothing has passed at all. A lot of times we might call that the Y-intercept when we get more technical. It's right here where it crosses the y-axis. So that is at 10. So in this case, 10 is my start value. Okay. And if I wanted to write an equation for that, I'm going to look back here. My equation can be dependent equals rate times independent plus start value. So my equation will be dependent, y equals rate, which is 5, times independent, which is x, plus my start value, which is 10. So y equals 5x plus 10 would be a good equation for that graph. Okay. Looking at B, in this case, all right, this one's kind of tricky. Xy here. Let's see if we can. X is 1, 2, and 3, and y is 9, 15, and 21. So to find if it's linear, we need to check if it has a constant rate. So look, x is always going up by 1 here. So that's good because then I only have to check if y has the same rate every time. From 9 to 15, it's going up by 6. And from 15 to 21, it's also going up by 6. So every time on my small table that I have here, it does look like I have a constant rate. So we're going to say that yes, this is linear because there's a constant rate. Okay, and that rate, how much is y going up by every time x goes up by 1? The rate is going up by 6, so positive 6. Okay, And then 3, the start value. This is always really tricky. This table does not start at 9. 9 is after one unit on x has already passed. So if I'm trying to go back to the start value, I need to find out when x is 0. So if I go back here, I'm going to go back 1 till when x is 0. That's going to make y go back 6, and it's at 9 right now, so it's going to go dropping all the way to 3. So in this case, right there, my y value when x is 0 is 3. So that means my start value is at 0. My start value is 3 when x is 0. So if I was going to write an equation for this, I would say, again, my dependent, y, equals my rate, which is 6, times my independent, which is x, plus my start value, which is 3. So I think this equation will look like y equals 6x plus 3. All right. So this equation, y equals 7x plus 100. So you just need to see, like, is this in the form dependent equals rate times independent plus start value, or could you make it in that form? Well, it absolutely is in that form. Dependent equals rate times independent plus start value. So we could say, yes, it's linear, and because it follows dependent equals rate times independent plus start value. Okay, and by the way, if this said y equals 100 plus 7x, I hope that you would notice that because of the commutative property of addition, you could change it back to y equals 7x plus 100. Okay, so think about your properties and don't just say, is it in that form already? But you're allowed to do some of your properties and play with it a little bit. Okay, so and then problem 2. So what's the rate? Well, the rate is what's multiplying the independent variable. So it looks here that my rate is 7. And then 3, what's my start value? Well, plus the start, the number that's being added on at the end, is a positive 100. So my start is 100. Okay, I hope this gives you a little bit of understanding of linearity and how to relate a table to a graph to an equation. And we'll practice with this more, but everything on here is definitely going to be on the next quiz.